Let's move now to the article, paper number 75, Beam, Twin, and Between, a conceptual engineering approach to formulate digital twin in construction. Fabiano, Correa, are you ready?
Yes, I'm here. Can you hear me?
Great. You can begin, please.
Okay, thank you. Let me share my screen. Okay. So I'm Fabiano Correa. I'm from Brazil. I'm a professor on the construction department in the University of São Paulo. This article deals with being, twin, and between, a conceptual engineering approach to formalize digital twins in construction. It's really a shame that I could not make be present in person in this ISARC that is in Colombia. It's so near of my country. It's great to have this conference on South America. Maybe in other opportunity, I could go to Colombia and know the Universidade de los Andes. But let's talk about the motivation and context of this work. I think all of us hear a lot of this Industry 4.0 concept and the associated technologies like digital twins. It's became in the media, even in academia, like a buzzwords. All people that are working with technology in construction tends to use those words, and it starts to be difficult to really understand what should be digital twins, specifically in our sector. And also, there is a distance from people related to the architecture, engineering, and construction to really know the context of previous industrial revolution technologies, because this 4.0 mentions the other three industrial revolutions. So it's a context very much focused on manufacturing. And also there is a uniqueness in our sector of building information modeling. It's a process, a methodology that is very specific to us, and it causes confusions. And there is a lack of a clear vision about digital twins in our sector. And many people use BIM and DTs as the same thing, be it as software vendors or researchers with background in traditional construction. They mixed these two concepts. The methodology of this research started with a literature review, searching for works mentioning BIM or building information model and digital twin. In the scope, in the horizon between 2017 and 2022, I found in the Web of Knowledge 258 articles based on this string. And I make some analysis. I created a graph of citations, try to see where is the seeds of this misconception in this BIM and twin mixing and became the same thing. And also I did some semantic analysis, and I find some frequent terms or concepts. And one of the results is that we could see there is two different visions based on two different most cited articles. which are the construction with digital twin information systems, and towards a semantic construction digital twin, directions for feature research. And based on these preliminary results, I adopted a conceptual engineering approach to try to define or redefine digital twin in our sector. Conceptual engineering is different from the more known methodology of conceptual analysis. The David Chalmers' article defines conceptual engineering as the design, implementation, and evaluation of concepts. And conceptual engineering includes or should include designing a new concept as well as fixing an old concept. In this case, I think we need to fix this digital twin concept because it is really confusing and mixing with the BIM definition that is older in our sector than digital twin. And we have a lot of paper doing this comparison, seeing the difference and similarities. I pick up just one to put it here. BIM is designed to support efficient design and construction, and digital twins are designed to improve the functional and operational efficiency of the physical asset. So here we see a clear difference. BIM is not designed to work with real-time data. For sure, you could put real-time data with dashboards. You could include real-time data inside IFC. There is entities there to put this data, but BIM was not designed to work with this kind of real-time data. On contrary, digital twins work specifically with real-time data to perform digital simulation and analysis of its physical counterpart. I think the most important part is this performing digital simulation and analysis. This is really the difference that I'm searching for and will use in creating this new concept of digital twin. And BIM dimensions or data integration, we could use as example cost and schedule. And for DTs, it integrates real-time data to improve buildings or infrastructure interaction with its users and environment. So I pick up all the concepts that I found in the literature review, all the difference, and start to play with them with focus in simulation. Different kind of simulation that we actually do today with BIM models, and more advanced simulation that probably we don't have yet in our sectors for our buildings or the building systems, or how an infrastructure ages through time or through use. But I try to make simulation really important for a digital twin. So in this figure, we see on the left the digital twin, and on the right we have the real twin. And then I broke up the digital twin in the digital part and the twin part. And each line or hierarchy of this figure try to do with some different part of the concept. So the digital part of digital twin exists inside computers, and the twin, it's with regards to the link or relationship that exists with the real twin. So through sensors on the real twin, on the object, we have a data flow that feeds our program that is inside the computer. And also this program is fed with representations, with models. And we have a lot of different possible models to fit on the program that is the digital twin. We have the product model that could be BIM, could be IFC models. But more importantly, we have the functional or dynamic model, the digital model that represents the behavior of the real object. And the digital twin should be very specific for the function or behavior that we are interested in. So the program is really the simulation. We have different kinds of simulations right now. Each kind of simulation needs a different transformation, for instance, of BIM models. BIM models should be transformed in a topology model to do energy analysis, or it needs to be transformed so you could do finite element methods. And if you need to, if you are interested in the construction process on site and maybe use a discrete event simulation, so you need to transform the schedule inside BIM in that simulation. So there is a lot of things that should be researched, that should be developed, that most of the current mentions of digital twin are not in dealing with that stuff. If you have a BIM model based on laser scanning of the ambient, of the environment, of the building, you have a very detailed model that probably could not be used for simulation. So this definition was trying to really focus on simulation. And then based on the results of one kind of simulation or a hierarchy of simulations, we could start to manage the building, the infrastructure, the construction process. And we could, in this definition, in this diagram, you could plug other different Industry 4.0 technologies like AI to make decisions in the management to support human decisions. You could use DT-driven CPS to autonomous machines. You use IoT sensors to provide the data flow. You could use AI to interpret data if it is images from cameras, from drones. So this is the concept created for digital twins. And I would like to talk a little bit about the importance of simulations and digital twins, the challenges that exists. So I highlighted 4, which are the DT uses. So if you want a DT from on-site production, you should have to deal with the unpredictable behavior of human labor. If you are dealing with operation and maintenance, you should really integrate different sensors to represent building and its systems. And if you are monitoring the health of structural health of infrastructure, you should have a model to predict the aging or the maintenance period of that piece of infrastructure. Another challenge is how to automate on-site monitoring and should make a decision of instrumenting the construction site against putting some sensors in the material, equipment of and/or workers. The third challenge would be the digital fabrication and automated construction. You could have cyber physical systems controlling this equipment and machines, and DTs could be the control, the software part inside the CPS. And also, and very important, we have the people and education, because many people of our sector has difficult to understand, to grasp, to create models, and to analyze data. So we really need to change our approach in academia to taught these topics for them. And so my conclusions, DTs are core components of Industry 4.0 and its digitalization phenomena. It will help in promoting increasing productivity and competitiveness in construction industry. Between the concepts of BIM and DTs, there are many technological differences. Future research should address how current simulations could be leveraged to work with enriched BIM models seamlessly, the interoperability problem, and DTs should provide not only better management and maintenance practices, but also feedback for design and planning optimization. So that is my presentation, and gracias. And if you have questions.
Thank you so much, Professor Fabiano Correa. Any question? Any comments? I have many comments and I have many questions, but I will not tell it today. But I agree totally with you, Professor, about how to fix the definition of what does it mean BIM, what does it mean digital twin. And we find in the literature a lot of definition, and these definitions are given mainly by industrial. You can have some definition given by example by Siemens, definition given by Dassault, definition given by other industries. And we have also the definition given by academic. And it is the occasion to establish this kind of definition for the lecture, for the student, for the PhD, and for us as professors. I agree totally with you about that. And we have to focus on what is the definition, the academic definition of digital twin and BIM and DT, but these are the main difference between them, because it is very important that we know the context and why is important for that. And thank you so much for that. And thank you for your sharing for this academic definition. And this is the occasion to do it today. Thank you.
Thank you.